Welcome everyone to this week's IPLD sync meeting. It's March 1st, 2021. And as every week, we go over the stuff that we've worked on the past week and things we plan to work on, and then discuss any open agenda items. I start with myself. I've worked on the JS multi-format stuff for more generally spoken JS IPFS, but I start with JS IPFS UnixFS. And I did a small patch that just used the protocol buffer stuff, the new one. But then I decided to just, because like when I was integrating it into IPFS, it turned out the whole like CID is different and so on. I just tried to get all the JS multi-formats into JS UnixFS. And it worked. So there's no JS IPLD in the branch I have. But yeah, so we'll see how this works with JS IPFS. The interesting thing, I think, was that we were talking about like also like abstractions or missing pieces that JS multi-formats doesn't have. And so what JS IPLD was doing, it basically combined the encoding to build blocks and store them on disk in one thing. And it kind of felt strange that all this is bundled in one thing. But when I did the porting to the new stuff, I found out like it's actually quite useful. Mostly for writing tests, because you just always do the same steps. You always do encode this thing, get the CID, store it somewhere. And if it's just like a single step, that's quite convenient. So I'm still not sure, like, yeah, if we should end up with similar abstractions again. Probably it won't be called JS IPLD, but perhaps something else, or it would be part of JS IPFS. I don't know, but it's just like it kind of like turned out to be quite useful having this in one step. Yeah, and I will just go on with doing this in the next week and see how it goes, and hopefully, I get something working. Next is Eric.
I don't have a ton to report that's fresh and new this week, but I will briefly remind folks in case they're interested. I made a bit of an exploration report about fixture file formats. If anyone wants to comment on it. There's been a PR out for a while now on the link system in Go IPLD Prime, and that still hasn't officially landed, but for the record, as far as I'm concerned, it's fine to build on. The reason it hasn't landed yet is I had some more conversations with the other people who are interested in the maintenance of our other Go libraries, like Go multi-hash especially, which I ended up accidentally half replacing in the course of this PR in Go IPLD Prime. And it sounds like we're agreed that we're actually going to try to update a bunch of stuff in Go multi-hash upstream. So that's kind of exciting. I'm a little daunted by that because it's one of our older libraries that is highly transitively dependent upon. So we'll have to be very careful about making changes to it. But that's probably what I'm going to be up to in the next week. So there was some work I did as part of this link system PR that started using a bunch of standard library hash interfaces, which is a common thing in the standard library in Golang, and is supporting of streaming hashes. And I did a bunch of work on making the import paths such that you could compile your program without transitively depending on a bunch of unusual hash functions, like, or not even unusual, but just not in the standard library. So like SHA-3 is not in the Golang standard library, so you're pulling in more transitive dependencies if you use it. Trying to migrate all of that stuff to a reasonable plugin system so that you can choose whether or not you're going to have them in your transitive dependency tree and end up in your binary. So the current state of Go multi-hash forces you to have all these things in your binary, and we're going to fix that. So that's going to be my fun week ahead. And then the link system thing should presumably get rebased on top of that. It shouldn't have any outward facing changes, really, just putting things in the right upstream.
Cool. Next one is Will.
Sure. I guess to provide an update of where we've been, and this is as much reporting on behalf of Hannah and Alex as myself. There is a repo that now has taken shape called IPFS/GoFetcher, which provides an IPLD primed fetching interface. And that will allow us to transition to that from the current Go Merkle-DAG based fetching interface that is used through IPFS. So this is the next step of IPFS or IPLD prime in IPFS work. If you have comments on what that interface looks like, that repo is the place to put them. The next pieces that are happening and hopefully land in place in the next few days this week, using the link system branch that Eric mentioned, probably we will either make a new interface, likely not in that repo, but I think we haven't figured out exactly which repo it'll end up in that makes the most sense for the current add and remove interfaces that Go Merkle-DAG exposes. So we found that the interface that is Go Merkle-DAG is actually 3 distinct interfaces. There is I would like to get some data based on a SID, which will both attempt to get it from your local data store, but also will potentially invoke network things to fetch it through BitSwap or GraphSync, or it'll do this whole networky thing. So that's what GoFetcher is it's the, I would like to get data, please. Then there's a set of interfaces that are just for the local data store. Like, I would like to add this data into my local data store, and I would like to remove this data from my local data store. And that's really a codec serialization thing that the link system storing has something close to it in that it can serialize a DAG into a byte stream. But we would like to serialize a DAG into your data store, please. So that's a slightly higher level thing that just builds on top of it. So we'll put that somewhere and remove a DAG from your data store, please. And then the third one is like, I've got Unix FS and I would like to add a file to a directory. So there's this set of mutation-y things. And those may just sort of happen in the IPLD prime thing, or we may have some helper functions to help move towards semi-standard ways of doing things so that we don't have to change it in multiple places. Anyway, so that's in flight. The other work I did last week is I took the Git codec. There was a sort of non-standard way of thinking about Git objects from IPFS. And I rebuilt that on top of IPLD prime nodes instead of IPLD format nodes. And there's a PR that could also use review on that. More to come.
Thanks. Any updates from anyone else? Else we get to the agenda items. So also feel free to add agenda items. So I have there the kind of like update from Daniel and also talking about Go Codec DAG PB.
Yeah, so initially I was going to ping Rod about this on Slack, but I thought I might as well, since it's a Monday, I might as well just bring it up here. So to recap from last week, Will was asking what's the difference between Go IPLD Prime Proto and Go Codec DAG PB, because they're both seem to implement the DAG PB codec. I don't want to say spec because I think that's only the latter. But essentially, we have to choose one, right? Because we don't want to maintain both. And something that Hannah said last week is it doesn't really matter which one we choose as long as it works with Unix FS data and uses IPLD Prime. So I picked up this task of, okay, let's decide which one we want to use. The advantage of the Prime one, which is the one Hannah wrote, is that it uses, I think, the same code that Unix FS uses, which is the one from Go Merkle-DAG. But it's not API-wise, it's not very nice in terms of IPLD Prime. And it also pulls in Go Merkle-DAG as a dependency. So that recursive module dependency is technically not a problem for Go. It builds fine, but in longer term, it would be a problem to have. It would cause problems like It's just a web of dependencies that's not very nice at the level of modules. The other one is DAGPB, which is one that Rod wrote at some point. And the question was, is that actually compatible with UnixFS data? So what I did was, there's a package in Go Merkle DAG called PB, and it has a table-driven test called test_compat, and it uses the encoder and decoder for DAGPB in Go Merkle DAG. And it has a bunch of test cases like no links, a bunch of links, some data, blah, blah, blah. And I essentially rewrote that using DAGPB, and it mostly works. There's a few test cases where it errors out. And this is the tricky bit. This is where I want to ask you all if you think this will cause problems for reading and writing UnixFS data. Some of the tests that fail are to be expected. They're the ones like having a nil links slice as opposed to having an empty links slice. And that's fine because they encode to the same thing in protobuf. So it's just a different way to represent them in Go. But as long as they encode to the same thing, that's fine. At the level of the encoding, that's fine. The other class of test cases that fail. Oh, I might need to reread that. My apologies. The other test case that fails is essentially invalid links. So links that lack a hash, that kind of thing. So so I guess the question there is, I've seen that the spec does say that. It does say that the hash technically is optional, but should not be treated as such when reading and writing nodes. But has anybody verified whether UnixFS v1 has such links?
No, and this is a problem that now you're touching on, which is a good thing. So part of the issue we had with the spec for DAGPB was just getting input up the stack into UnixFS and people that actually use DAGPB. So there's a lot of brave assumptions being made there about what can and can't exist and what to deal with it, and just getting answers for things like what happened, because what happens if I get a hash that it's not a valid multi-hash or is 0 bytes? Like what do I do with that? Am I likely to encounter that anywhere in the wild? What is the likelihood of that? Getting answers to that has been very difficult. So there's some brave assumptions made in that spec that may turn out to be problematic. And the spec is not set in stone. It is our best effort at trying to bridge the world of old DAGPB to this new world of data model, and that's what it is. And that's so DAG. What is it? Go codec DAGPB bakes in that spec as it is. Go IPLD prime proto. It basically just says, here's Go Merkle DAG that's doing this PB node, PB link stuff. Let's just wrap that around whatever comes out of it and not make any assumptions at all. So there's, it'll take whatever Go Merkle DAG gives you. But what Go Merkle DAG gives you is basically it's just almost stream of consciousness that arises out of the bytes with no checking. Like it's raw PB, and we know that that's not the case. Like, because on the encode side, there's some rules. So it's complicated. But if you go to that link, it's kind of hidden now because the doc got updated. But I wrote a whole lot of stuff there about the differences, and it is good. It's good that you're touching on this now and getting into real world data. And I can't say for sure whether the tests that you're seeing failing are actually accounting for real world things or just accounting for things that are in the code. My suspicion would be the later, that this is stuff that they see that has been seen in the code, and we should test this as an edge case. But is it something that is going to arise out of real world data? I suspect not, but yeah.
Yeah, that was my assumption as well, because I can't figure out a case where an invalid link would be useful. I mean, the only possible case I can think of is, we decoded some data. We can't really use it, but let's encode it again and pass it somewhere else. But if you do that, you might as well, use the original bytes. So yeah. I don't know. So I guess what I'll do is just continue with this, but continue using Go codec DAGPB. But in the case that we do find that UnixFS does use this kind of semi-broken data, I guess we get into a territory of making the spec more lax to actually be compatible with UnixFS. Okay.
And yeah, and that's completely reasonable and expected that once we hit the real world and we find out these assumptions don't hold true, then we would change it. And you'll see a couple of other places where that matters. Right now, there's even a discussion about the T-size optionality occurring in the JS IPFS side, because there was this assertion that happened last year that, hey, let's make T-size something that we don't require implementations to write correctly, but let's put one in there anyway and defaulting to 0, something like that. But the spec says this thing is optional, and so that should be handled at a layer above, where if you really want to just insert 0, then you should do that. But right now it's an active discussion whether maybe we should encode that in the spec and make it non-optional and just default it to 0. I mean, I'm glad you're in this world now. You can have it.
It's not my problem. The only other thing I was going to say about this is Hannah did say that Go IPLD Prime Proto has a few shortcuts for the sake of performance. So she said we might want to port some of those over to DACPB if we end up using DACPB. So you might see some PRs.
No, don't treat me as a blocker. Like, just do what you need to do to make it work. Yeah.
Cool. Yeah, so that was me. So we'll most likely do. We most likely will use DACPB because I can't really experiment any more than what I've already done. And like you say, it's hard to tell if the tests were driven by real data or not. So.
And here's another thing, actually. So, Go Merkle DAGPB also has additional tests that I put in there as part of the spec process. So, it's going to be even harder to disambiguate what's where for what, because when I was doing that testing work, that was really testing the edges of, what is a PV node and PV link, and what does this thing produce in these different states, and finding that there's a couple of different states where you can get the same bytes from different data. And so that was part of the process of getting to the spec, like that we should have one way to get to the same data, like one data equals 1 bytes. So it's just there's a looseness that has been around this whole area for a very long time that is inherited from protobuf, but also just from the, let's make it work and move on kind of thing, which is fair enough in these early things, but we only just now have been going back to try and formalize it. So there you go.
Yeah, I just realized the test I used were test compat, which are the ones you wrote. So
that's mine. There you go. Yeah, right. And those you'll see those tests have been mirrored in Go codec DAGPB, but I've commented out some of the ones that I've asserted shouldn't be passing. So there is the same tests are there in Go codec DAGPB, slightly different format, but there's a few removed, and I think they're still in the file. And I've just put notes saying this is bad. So that compat test is me testing the limits of what Go Merkle DAGPB does, and then me having opinions about what it shouldn't do and doing that in Go codec DAGPB. So fun, lots of fun.
Oh God, I just realized I should have talked to you before I did this, because what I did, the table I ended up with is basically the same one that you have. Anyway, moving along. Do you think there's any other tests I should look at?
Those tests, by the way, are also mirrored in JavaScript. So there's 3 instances of them, with Go Merkle DAGPB having the most relaxed and wide view.
Okay. Last question, promise. Any other tests that you think I should look at? Because besides test compat, I didn't really find any tests that seem worthwhile.
Not in Go Merkle DAG, no.
Okay. I can look at the JavaScript side of things, so I wouldn't expect many great tests there, but still might be useful to see what. So I can find out if we have tests, or basically, so probably we have tests in UnixFS rather than in DAG.
Yeah, true. Because this is the thing that when I was going through this, I was just hungry for real world data, and it's just like, where do I get representative real world data from other than just picking someone's random DAG? Like, it doesn't exist, and it's not encoded in the test, and it's a real problem. I'd love to see real world data that tests all the edges, but no one's really collected that, and that's really hard to collect, like just in a day kind of thing. You really got to do a lot of research for that.
Daniel, just in case, as Rod said, currently the Go codec DAG-PB is the same as the JavaScript one. And basically this is what I currently work on, getting this new codec into UnixFS. So just in case you make any changes because of like edge cases or whatever, please like take notes or something so that we can also then update the JavaScript version, because yeah. Yeah, cool. Yeah, and so in case, yeah.
No, go ahead.
No, it's just like, so yeah, feel free to ping me. So I'm not sure like who's officially responsible or something, but like if you ping me, I will make sure that, yeah, we get this worked out in JavaScript.
Cool. I just want to ask, Rad, can you clarify when you say real world data that pushes the edges? What do you mean exactly by this?
Okay, what I mean is DAG-PB is the most used codec in IPFS.
Yes.
Like it's like the other ones don't even rate a mention, as much as we'd love DAG-Seaport2. And so this stuff is out there in the wild being pushed around, and it's hitting edges. And we have a codec on the decode side that is extremely sloppy right now. So on decode, Go Merkle DAG-PB will, there's a lot of ways that it'll just say, yeah, that sounds good, I'll use that, cool. And it'll decode really sloppy bytes. On the encode side, it's more predictable. There's a determinism to the encode, but the decode is very undeterministic. So some of the decisions that went into the spec was closing some of those holes and saying, well, we shouldn't see bytes that are of this form, because we don't see an encoder that we have that is producing them. But that's a very brave assumption, that those things don't exist, because there's other things creating DAG-PB data. Right. And there's also a lot of historical DAG-PB data that still lives. And so real world, meaning this DAG-PB stuff out there that people are passing around in IPFS that may have existed for many years, that pushes the limits of what we do. But how do you filter that out and find something that's interesting and representative?
That's basically why I was asking, because like, what does representative mean? Because like, when I first learned about IPFS, I did a shitload of very like weird protobuf stuff. That's not representative, right? I mean, they're still on GitHub, you can still like import them and stuff like that, but this doesn't mean that you should support them. Yeah, from that perspective. But no, it kind of answers my question. You are aware that I forgot which subsystem it is. Something to do with geolocation within libp2p is entirely protobuf, DAG-PB based without UnixFS.
I knew there was some protobuf stuff. I didn't know they were using DAG-PB. But see, and I never stepped up. I never stepped up the level to UnixFS, which was my intention to get there, because it's like this weird onion that we do with PB decoding.
Yeah, it's just something to keep in mind. I unfortunately I don't remember exactly which subsystem it was. I just know there is a thing.
If they're using the Go code right now as it is, and even the JavaScript code, that's sort of accounted for in the current state. The spec accounts for how that works now, but DAG-PB is interesting because we're talking about data that could have been created 5 years ago, and I'd love to get my hands on some of that data and see if there's any novelty in there. But yeah, totally. That's not going to happen.
Will the data end up in some cross-language fixture kind of thing? Because I was wondering if the Rust IPFS people obviously have their own DAG-PB encoder thing, which, I mean, I've seen, and I think I fixed some things, but I've never really looked into how it actually works or if it does the right thing. And I would assume that it probably doesn't do the same thing as the other ones do. So I guess it would make sense, because they're kind of I would still consider them early. So I think breaking their stuff shouldn't be too bad, I guess. But I guess we should also keep it on the radar, or I will keep it on the radar, that we should also probably have fixtures for them to just see what they're doing.
I wonder if there's any old OpenBazaar DAG files floating around, because they would have been pretty early users and creators of DAG structured data that could be used for fixtures. And they might be fine with providing access now that they've kind of shut that down and moved on a bit. I have no idea.
Yeah.
I'm just throwing that out there.
Cross-language test features, that's, I'm handing that over to Eric. It's his responsibility now. My plan for this was, I was working my way to DAG JSON. And I wanted to get that tied up so I could then use DAG JSON to insert back into these other things and represent things in DAG JSON and use them as test cases for pushing the other formats around. So it's a circular thing. But DAG JSON isn't quite finished up. It doesn't work in Go IPLD Prime, and that's sort of left on the floor for now. So, but Eric's taking over that baton.
Okay, cool. Yeah, I just reminded me that also, like, even in Rust IPLD, there's a DAG PB codec, which I probably should check out. Yeah, cool. Anything else? Let me check the agenda. No. All right, does anyone have any other items or wants to discuss anything?
I have a couple of questions.
Yeah, go ahead.
So I have one question for Eric about, and if Michael was here, I would ask him too, but so the textile team has found ourselves in need of a hash consistent sorted data structure. I've been playing around with the JavaScript stuff. It's lovely, actually. And I think Michael's chunky trees library is a nice implementation of that. Do you know of any Go implementations of something like that, even that I could build on?
I don't know. I don't think that we've written one yet. I don't know how hard that would be either. Probably not super hard.
I don't think so. I mean, I know that there's one of that paper I linked you guys to. I can't remember what that was called, what that paper was. But anyway, there's an implementation of that one that's like has some similar ideas that's been implemented in Go. So I'm guessing a bunch of copy pasta could be done there to make something compatible. But I was just wondering, because we'll do it if it doesn't exist. So
the path that I think we had on that was Michael was trying to cement something, like trying to really get to some end point where we're like, this feels good enough, and then perhaps propose to do work that provides multiple implementations of it. That's sort of on hold at the moment. Michael is pushing that. I think he's got his interest in IP SQL, and he's still pursuing that. But Michael's prioritization has changed quite a bit, as has some of ours as well. So if you do end up pursuing that further, it'd be great if you could keep us in the loop, and we might be able to connect many dots together.
Cool. Yeah. I mean, if we do, it's going to be pretty minimal, like implementation just to satisfy our primary needs, but it could provide some baseline for something else. Because ultimately it's probably going to end up being a pretty lazy data structure that we need. And so it'll be pretty minimal, just like take some data, figure out where in the tree it belongs, and then like that's about as far as we'll ever have to go. But anyway, that's useful. Yeah, useful.
So we did have a recent fresh implementation of some of the HAMP stuff, which is, so it's also a hash tree, but it's almost the opposite of sorted, right? So probably not the exact implementation that you want. But we were working on one of those really recently, and Daniel was actually just wrapping up a bunch of the stuff on that. And so it's probable that that would also be a really good example of how we would do it. And then just the sharding logic, I'm sure, will be different, but a bunch of the rest of the like code organization would probably be very reusable. So that could be helpful.
Oh, that would be super helpful. Is there, where should I look for that?
I think it's github.com/IPLD/code go-adl-hamped or something. I made that up off the top of my head, assuming that our naming scheme is consistent.
Okay, I'm just gonna make a note.
It's not. I guess wrong. We'll find it somewhere.
Cool. I'm
Oh, go-IPLD-ADL-hamped. One more word than I thought.
go-IPLD ADL hash.
Hamped, H-A-M-T.
That's great. That's very helpful. And then my other question was more of a comment, which is what I call questions that are actually really in the form of a comment. Usually you get them at conferences and things like that, where people pretend to ask a question, but are really making some snide comment about something you presented. But I just wanted to mention that there may be some real world edge casey type hackarounds in some of that. Originally, we'd written a JavaScript implementation we called IPFS Lite. And now it's been migrated over to some IPFS repos, and it's called like IPFS DAG service, I think. And in some of those tests, there was a bunch of really ugly, hacky things to like make some of the block API stuff work with older like Unix FS readers and writers. It's a bit out of date now, but there may be, like, it's not up to date with the latest multi-formats JS stuff, but there may be some comments like, note, this is here because of incompatibilities between CIDs, like libraries, and those notes might be valuable. So just wanted to point that out. Also, that's kind of like an interface that I just recently redid, actually. I kind of wish that IPFS, JS IPFS built their like DAG service in a composable way like that, so that you could just swap in a different one. So if you're in there messing around, it would be wonderful to like make that DAG resolver a bit more pluggable. Just a suggestion. Because I know that Irakli wants that as well for some of his work. So that's my comment.
One of the tasks that we have as a proposal to take on some work is to make the whole thing more composable. Like, just let's just stop doing this monolith thing and make it so that you can just take the useful bits that you care about for your application and piece them together.
Yeah,
that's
awesome.
That's an ideal that a lot of us really want to aim for, but there's a whole lot of work in that we have to make sure we can, that is a legit priority compared to all the other things we could be doing. So, but that's a really good bit of feedback, and maybe I should jot that down. So DAG service for you is the biggest piece of that puzzle. Is that what you're saying?
Well, DAG service is huge because it encompasses like so much of what you actually really only need IPFS to do in a like lightweight browser environment. I need to fetch some DAGs, pull them together, and display something for you. And all I need for that is like access to a block store and a libp2p host and a DAG service that knows like how to deal with those, and that's it. I don't need pinning APIs. I don't need, IPNS. I don't need pub/sub. I don't need like all these other submodules. I just need to fetch some DAGs. Half the time I don't even need to put it. So like I barely even need to be able to like, I need minimal bit swap. And then like as an added bonus, one of the reasons I was pulling it apart and rebuilding our own is because instead of bit swap, we wanted a graph syncy type protocol, because our two peers, we know that they are tracking the same DAGs. So there's no point in like a more general bit swap. They might as well just do a sync together. And so being able to swap in like those components are nice as well, obviously.
Cool. Yes. Yeah. This kind of thing has been like on my agenda since I joined Protocol Labs and worked on IPLD. It was like, oh, I just need IPLD. I don't need all those like IPFS things. Just just networking, storage, IPLD. That's it.
Awesome.
But yeah. So eventually we'll see. Cool. Anything else? Nope. Then thanks everyone for attending, and see you all again next week.